Hello, my name is Mrs. Cassandra Dyson, and I teach at Hammond, Eastside Magnet Upper in Tangipahoa Parish. As an educator, I am most passionate about understanding the needs of my students. My focus is to reflect on best practices and research methods that will lead students to mastery. I want to always make sure students are in a conducive learning environment that allows them to focus and communicate positively. It is my hope that students are able to make real-world connections with every lesson they complete. All in all, I not only want students to be high school and college ready, but to be ready for the real world. The students in the video are 8th grade students. The content is Tier 1 Eureka Math Curriculum. The objective of the lesson is to note that a system of linear equations or simultaneous equations is when two or more equations are involved in the same problem and work must be completed on them simultaneously. Students also learn the notation for simultaneous equations. Students compare the graphs that comprise a system of linear equations in a constant rates to answer questions about distance and time. Prior to the lesson, I established criteria such as specify vocabulary relevant to the lesson, provided materials that included ruler and graph paper, and advised students to use cheat sheets. Students were given an anchor task to activate prior skills from the previous lesson. In that lesson, students learned how to graph equations in slope-intercept form, which is y equals mx plus b. While annotating the lesson, I was intentional with questioning by making sure students justified solutions. I made sure to include peer-to-peer interactions and Kagan strategies to ensure every student was involved in the learning process. I had students reflect on identifying slope and y-intercept throughout the lesson. This lesson connects to my overall goals because we utilize real-world scenarios when mastering concepts about distance and times. Students were able to identify the relationship between slope and constant rate and note that they are the same. Some important information about students in the class is they are also enrolled in my Algebra 1 class. There's only one student with an IEP and 9 students who need additional support to achieve mastery on the LEAP. The students are with me every day in double block, in which they go directly into Algebra 1 second block. Some adaptations include 20 minutes of interventions daily prior to the lesson. During this time, the students are separated into 5 groups, with Math Equip being the most important because it addresses learning gaps that are crucial to the current module. In addition to that, I use that time to address exit tickets from the previous lesson. I pull about 3 to 5 students from their intervention groups to address feedback given on the daily assessment. The goal of this is to allow students an opportunity for one-on-one questioning before moving on. Another thing that I've implemented are group leaders. These individuals have specific duties each day that range from helping their peers to ensuring the class flows with no time lost.
Have a seat. Get started on bell ringer.
Ranger Shootout Basketball Tournament. Tonight is the last night for this tournament. We encourage all students and faculty and parents to join in on supporting our team. Tomorrow is also a club day schedule with a PBIS teacher.
Paper for so that you can write down your objective. So that's your you should have your workbook pages, your ruler, and your cheat sheet on solving equations, or whatever cheat sheet that you can use to help you throughout the lesson. Alrighty, so let's go ahead and get in plan. We're going to have 2 different functions or 2 different lines. So when looking at this particular coordinate plane and the 2 lines that lie on this plane, go ahead. Where the point of intersection, that is exactly what we're going to be getting into today. That point of intersection, okay? So based off of that information, okay? So let's go ahead and write your objective. The number 2 pointers, what variable represents the number 2 pointers? X. And what represented over here? To X, okay? So that should look like what? If I'm adding 5 more to X. X plus 5, and what does that equal? Equals Y. So this is the correct equation, okay? So going on to question number 3. Give me a pair that would actually equal up to 30. Go ahead, Ms. Carolyn. 9 and 4, yes, okay. So let's add that to our table, 9 and 4. Our first table, if we compare these two tables, okay. So if 9 and 4 equals up to 30 in the second table, and it also equals up to 30 in the first table, that lets us know that those values are in common. So keep that in mind, the 9 and 4 in both tables. And we're going to come back to that in just a moment, all right? The next thing I want you to do is I want y'all to open y'all's Chromebook and go to Desmos, because we're going to use Desmos to actually do our graphing. Typing how many into the computer? There should be 2. Method can we do to make sure or verify that 9, 4 is our point of intersection? Go ahead. Good job. Plug it back into the equation, okay? So when we plug that back into the equation, let me go back. When we plug that back into the equation,
you write 2 and then you put your 9 in parentheses.
Good.
Plus 3 and then put the 4 in parentheses. And then it'll equal 30.
Good job. Okay. Okay.
Multiply 2 by 9.
And that is?
18. And 3 times 4 is 12.
Good. Equals?
Equals 30.
Great. All right. And so my second equation, can someone from Alexis's group walk me through?
5 plus 4.
Okay. And basically that means that 9 equals what?
9.
Good. The objective, demonstrate the effect on the graph of a line when there is change in the circumstances involving time with constant rate problems. Okay? All right, so we want to talk about Paya typing at a constant rate of 3 pages every 15 minutes, okay? So you guys don't have this example, but I do want you to document with the things that I underlined. Please make sure you write it down because it's relevant information that we need to know, okay? So Paya types at a constant rate of 3 pages every 15 minutes. Is that important information? Yes. So let's go ahead and I want you to write that down. 3 pages every 15 minutes. Now, remember in the beginning of the lesson in the objective, we talk about constant rate, the formula for constant rate. One person tell me again, what is the formula for constant rate? Go ahead, Lila. Distance over time. Good job. So how could I represent Paya typing at a constant rate in the constant rate formula? What would that look like? C equals 3 over 15. Good. We have to simplify everything that we do, right? So just as a quick mini lesson, how would I simplify 3 over 15? Divide both top and bottom by what number? 3. By 3. So that means that 3 divided by 3 would be, and 15 divided by 3 would be? 5. Good. So we wouldn't say 3 over 15. We would use the equivalent fraction of 1 over 15, okay? And Luke, can you tell me what's the difference between using 3 over 15 and 1 over 5? Okay. Does it represent the same thing, though? Does it still represent her same constant rate? Yes, because they're equivalent. Good job. All right. So, the next thing, now that we have constant rate, if you guys can recall, what is the relationship between constant rate and slope? Somebody said it. They're the same. Yes, they are the same. So keeping that in mind, since we know that constant rate and the slope are the same, can we represent this in our slope-intercept form? Yes. And can someone tell me what slope-intercept form is? Go ahead. Y equals mx plus b, yes. So let's write that down as a reminder. Y equals mx plus b. So we want to know, how will we represent that on the graph? So it's going to go into what we have already talked about, which is translating. And we literally just did this in algebra, okay? So we're basically going to be translating or transforming that graph to represent me starting 5 minutes early. So keeping in mind that my origin is my 8 o'clock time frame and I started 5 minutes earlier, someone tell me, what will this graph look like? Or how will it represent me starting 5 minutes early? So let's take some time and a couple seconds to think about what will that graph, or what is it supposed to look like if I started 5 minutes early? Now, before you guys think about that, you have to know what scale represents what. So you have to define your values. So X would be represented as the what? X is always the time. All right, and then Y would be what? Distance. And in this case, it's the pages typed, okay? So if X represents time, how is my graph going to be shifted to represent me starting 5 minutes sooner? All right, so in decimals, I want you to kind of keep the same formula. Let's go to a second line. All right. Per hour. How long is an hour? Well, if it says per hour, how many hours is that? Huh? That's right. But here's the problem with this. Y'all group leader got the right answer. So
Would I
group
say
leader
it?
on those formulas, as well as identifying the point of intersection, okay? Please remain quiet while you guys are taking your exit ticket and place it in the bin.
The lesson objectives were met because the evidence suggests most students were able to identify that a system involves two linear equations by graphing both lines on the exit ticket. The students were able to formulate equations based on the scenario and were able to identify the point of intersection as the solution to the system. If I were to do anything different, it would be to front load some information such as the graphs, since knowing how to graph was covered in lesson 18 and will be covered again in lesson 25. That way, students could have had more time to focus on the objectives. I allowed students to use decimals to graph rather than sketch on paper. If I were to do that again, I would provide the graph and only have them identify the point of intersection for time purposes. I also would have incorporated an error analysis with the relationship between representing constant rate and time in an equation. I found that some students were confused on which equation to add or subtract time from. However, they still understood the proper notation of the equation. The things that you may not see in the clip are the closing of the lesson. During that time, students are asked intentional questioning before they move on to the exit ticket. I wanted to give students who suggested and who struggled an opportunity to justify the concepts and objectives. If I found that a student still struggled, I allowed a peer to explain, or I referenced back to an example that we did together. We also did a time pair share so students could share 3 concepts they took away from example 2. This allowed me to listen to the takeaways of the lesson and led me to which students to focus on when given feedback during independent exercises.